We're going to continue where we left off, discussing whole numbers, what they are, integers, what they are, with going over how to do arithmetic with integers, because that works a little bit different than just whole numbers. For integers, if it is the same sign, you're basically going to be continuing to go deeper into that sign with addition. And what do I mean by that? If, for example, you're at positive 4, and then you go 8 more positive, you are now at 12. Very, very similarly, if you're currently at negative 3, and then you go 6 more negative, you are now at negative 9. The way that I like to keep my addition and subtraction integer rules straight is by thinking about it in terms of money. So, for example, for 4 plus 8, I would think that I currently have $4, I get 8 more dollars, I now have $12. For negative 6 plus negative 3, I would think I'm $6 in debt, I get 3 more dollars in debt, I'm now $9 in debt. And this becomes especially useful when you start switching up the signs with one another. So if I have $12 and then I owe you $7, I am now going to still have $5. That's sort of the visual of what would be going on with 12 plus negative 7 is 5. Very similarly, if I have $10, I owe you $14. Even after I give you all my money, I still owe you $4. So 10 plus negative 14 is negative 4. Very similarly, it works even if you switch around the order. If I owe you $13 and I get $16, after I'm done paying you back, I still have $3 left. But if I owed you $9 and then I give you back $7, I'm still going to owe you $2. So whenever you have mixed signs with addition and subtraction, you're going to end up subtracting the two numbers and then keeping the sign of whichever one's bigger in what we call absolute value. And basically, whichever number is sort of bigger, ignoring the sign, that's what's going to win, so to speak. So whenever I have 12 minus 7, that is 5, and 12 is bigger than 7, 12 is positive, so the answer is still positive. When I have 14 minus 10, that is 4, but 14 is bigger and the 14 is negative, so the answer is negative 4. When I have 16 minus 13, that is 3, and 16 is bigger, so that is what I'm ultimately going to keep the sign of, etc. Subtraction works very similarly, but it is probably the one where it's the most helpful to at least initially think of it on a number line. So if I have just a positive number minus another positive number, it's going to end up just working out that you would do 5 minus 8. That means I go past 0, 3 deeper into the negatives, and now at negative 3. If you notice, 5 minus 8 can be rearranged into negative 8 plus 5. Those give you the same exact answer. So if you end up there, you still just want to subtract and then keep the sign of whichever one is bigger. So in this case, the 8 is bigger and the 8 has a negative directly in front of them. My final answer is still going to be negative. If I have a negative minus a negative, whenever I subtract a negative, I move in the opposite direction. So subtracting a positive means that you're getting more negative. It means you're moving to the left. However, if I subtract a negative, it means I'm going to move the other way around. So let's see an example of that. If I have negative 9, and I subtract negative 4, I don't want to move 4 more in the negative direction. I instead move 4 in the opposite direction to end up at negative 5. So negative 9 minus negative 4, what people often change this to is that becomes flip both signs, the same thing as negative 9 plus 4. And that ends up working the exact same way, where you would do then 9 minus 4, that gets you 5. 9 is bigger than 4, so that's the sign that's ultimately going to stay. Similarly, if I do a positive minus a negative, it works very, very similarly. So if I start at 7 and then I subtract negative 1, that means I move in the opposite direction, 1, away from the negatives towards the positives to give us 8. So 7 minus negative 1 is the same thing as 7 plus 1, which is 8. And it works even if you flip that around. So if you have currently negative 3, and then I take away 6, well, I'm moving 6 further into the negative direction, and I end up at negative 9. So if it helps with any of these statements, you can always sort of flip the sign and then flip the sign, so to speak. And what do I mean by that? Well, if, for example, you have -5 plus 8, actually that's a bad example. Ignore I just said that. If I had -5 minus 8, it would be fine for the subtraction to flip the sign. That is the same thing as -5 plus -8 to give us -13. Or visually on a number line, -5 minus 8, -13. For -5 plus 8, that wouldn't be as necessary. I mean, you could turn them into a subtraction problem if you wanted, but I would, again, in my head, sort of think of the number line visual. I owe you $5. I get $8. After I'm done paying you back, I have $3 left, so that would end up being 3. Or you can think 8 minus 5 gets you 3. 8 is bigger, so we're going to end up keeping the sign of that bigger number. This one, for these next two, since they are subtraction, I would encourage you to pause the video and try it yourself, and then you can compare with what we get. So for these next two, I'm going to show you both on the number line and sort of the shortcut way. So for the first one, you're going to start at 4, and rather than get 6 more negative, because I'm subtracting a -6, that means I'm going to move in the opposite direction, and I will wind up at 10. Now, how could you do that the more shortcut way? Well, you can flip the first sign, flip the second sign. This is the same thing as 4 plus a +6 to get you 10. Similarly with the next one, if I'm at -12 and then I take away +9, I'm getting more negative. I'm moving in the opposite direction from the positive numbers, and I'm going to end up here at -21. And again, you can also think flip the sign, flip the sign. This is the same thing as -12 plus -9 to get us -21. So in short, if we're going to summarize, for addition, if they're the same sign and they're matching up, you're just going to go deeper into that sign. You're just going to add them up and then keep the sign. If there's a mixture between positive and negative, you're going to subtract them and then keep the sign of the bigger one. For the mixture between positive and negative, for addition, I would strongly encourage you to think about it in terms of money. So think of the negative numbers as debt, the positive numbers as money you have in your bank account, and actually, whenever you're first starting out, just actually visualize it on a number line. If you are doing subtraction, then if you have a positive minus a positive, you're just going to kind of straightforwardly subtract them and then keep the sign of whichever is the bigger number. If you're doing a negative minus another negative, it's going to end up working the same way. But anytime you're subtracting a negative, it's probably going to be helpful in general to go ahead and just flip the sign, flip the sign, flip the sign, flip the sign. Change that to adding a positive. Subtracting a negative is the same as adding a positive, which I'm going to write down here too. So subtract a negative is the same thing as adding a positive. That might be a good way to think about it. And if you have a negative minus a positive, that's the same thing as a negative plus a negative. Subtracting a positive and adding a negative are the same thing. So that's really the most straightforward way to think about it. But for any of those, draw down a number line, and whenever you're subtracting, move in the opposite direction. Now let's talk a little bit about order of operations. So for order of operations, you always want to start with parentheses. It also includes things like absolute value, which there's a whole separate video on, but whatever is inside parentheses you want to do first. Then you want to deal with any exponents. Then keep in mind that PEMDAS is a little bit deceptive in that multiplication and division are actually the same step. Multiplication and division are considered the same thing. You just work in order from left to right. And addition and subtraction are the same thing. You just work in order from left to right. So what I often see, happen on the internet or something is you'll have something like 3 divided by 2 times 1. Actually, let's change that so it's a little bit more interesting. 12 divided by 2 times 1 plus 1. Something like that, let's say. So what would you do with that? First of all, you would tackle the parentheses first. So 1 plus 1 gives you 2. drop down everything else. Then keep in mind that multiplication division is the same step. So technically, even though our brains want to do otherwise, we're going to just work left to right. We wanted to do the 12 divided by 2 first. So when I do 12 divided by 2, that's going to get me 6. I'm going to drop down the times 2. And then 6 times 2 gives me 12. And that would be your final answer. So again, you move from left to right. You start off with any parentheses first. We didn't have any exponents in that case. Then your multiplication or division, just going from left to right. Then your addition, subtraction, moving from left to right. And that's all that this is sort of cautioning as well. So let's take a look at some more complex examples here. So go ahead and pause this video and see if you can do each of these yourself before I go through it. So here, the first thing you want to tackle is those parentheses. So 2 plus 3 in this case gets us 5, and then again, I'm just going to drop down everything else. Then I want to move on to my exponents. So 3 squared gets me 9. Drop down everything else. Then I want to move to multiplication or division. I see that 4 times 5 is my next one. So then I'll have 9 minus 20. 9 minus 20, visually speaking, means I'm at 9. Take away 20, so I have $9. Buy something for $20. I'm now $11 in debt. That would be negative 11. Let's keep going. So let's say for the next one, we again want to tackle those parentheses first. 8 minus 4 gets me 4. We're going to square that, minus the 6 divided by the 2. Then we're going to want to go ahead and do our exponents now that we're done with parentheses. 4 squared gets us 16, minus 6 divided by 2. Then we want to do any multiplication or division. We see 6 divided by 2, that gets us 3. And then 16 minus 3 gets us 13. Notice how I'm writing each step individually. That is what you want to do. You don't want to try to do everything at once. Even now as a math professor, I still do everything one step at a time. Last but not least, this final one, I'm going to kind of shimmy to the side so we have a little more room. First thing we want to tackle are those parentheses. So 4 plus 2 is going to give us 6. Then we want to just move from left to right. So from left to right, I'm going to do the 5 times 6 first. That's going to get us 30. And then 30 divided by 3 is going to give us 10 as our final answer. Now multiplication and division, in some ways they're less intuitive because the number line does help, but it doesn't always tell you the full story here. And it's probably just easier to just kind of remember what the sign combinations are. So if you somehow have the same sign being multiplied or divided, so either a positive times a positive, or a negative times a negative, or somehow positive divided by negative, negative divided by negative, the resulting sign will be positive. If instead you have a combination of positive and negative, so you either have a positive times a negative, or a positive divided by a negative, negative divided by a positive, whatever order it might be, if the signs are different, it's a negative result. That's really a big picture what is going on here. And sort of, if you want sort of an explanation on why that's going to be, if I had something like negative 2 times negative 3, what that is really saying is, hey, I'm going to be doing negative 2 added to itself negative 3 times. So you're sort of working in the opposite direction for that reason. So you're sort of making that negative 2 a negative of itself. Negative negative 2 turns it into a positive 2, and then adding that to itself 3 times to give you your 6. Again, that to me it's actually not as helpful to think of it that way. I would really think same sign, always positive, different signs, always negative. And sort of, yeah, I'm just going to leave it at that. That's really the best way to think about it. If you're really curious more about the deeper theory of it, I'm sure if you YouTube it, you can get plenty of that. But I don't want to take up too much of your time going further into that today. So let's actually practice that though. So if we're going to practice that, go ahead and pause your video and try to practice each of these three for a minute, and then come back and check your work. So -7 times -5, they are the same sign, so that's going to end up with a positive 35. 36 divided by -6, that's asking ourselves, -6 goes into positive 36 how many times? -6 times. And then if you do -8 times -3, another situation where they are different signs, that is going to get you -24. Now I'm going to encourage you just to pause your video and sort of practice with these sort of mixed integers. Forgive me that there was a little bit of word rebelling against me in terms of the alignment, but hopefully you can still follow it, and then go ahead and check in with us with what you get. Okay, so 11 plus -20, these are different signs, so I have $11, buy something for 20, I'm still going to be $9 in debt. Here, working left to right, 5 minus 9 initially gets us -4. Going to drop down everything else. -4 minus 8 gets us -12. Drop down everything else. And then we get a final answer of -18. Here, if we have -2 times 5, those are opposite signs. This is going to give you -10. If I have -2 times a -3, those are the same sign, so that's going to get us a positive 6. Positive 8 divided by -4, those are opposite signs. That's going to get you -2. Here, if I have 2 times -5, that will give us -10. And then again, we want to do our multiplication first. 6 times -6, those are opposite signs as well. That's going to get us -36. Drop down the -4. Now I can continue moving left to right. -10 plus a -36, so you're getting more negative. That's going to get you -46 minus 4. -46 minus 4, you are again getting more negative. Already owe $46, owe 4 more. You are now going to be at -50. Last but not least, for this last guy, you're going to want to do the parentheses first. 5 minus 6 is going to get you -1. And then just drop everything else down. After that, you've done the parentheses. We have no exponents. We now want to check multiplication, division. Here, you want to be a little bit careful that negative is basically attached to the 2 in a way. So what I like to go ahead and do is rewrite that as 8 plus -2 times -1. -2 and plus a -2 are the same thing. And now it becomes a little bit clearer that -2 times -1 is going to get me positive 2. And then 8 plus positive 2 will get me 10. And I am to my final answer.